Shading of Venn diagram is the second type of questions in our syllabus for sets and Venn diagrams. So for shading of Venn diagrams, it usually they are of 1 marks. These are 1 marker, and we have two types of questions for shading of Venn diagrams. We can expect two types. One type of question is you would be given with the you'd be given with the set notation, and you'd be required to shade the diagram. That's one type of question. And second type of question would be you would now be given with the shaded region. You would be given with the shaded region, and you'd be required to write the set notation. You have to describe or write the set notation about the shaded region given. So generally speaking, these are the two types of question, and both these types of question are simply 1 marker. It's easy to score. You just need to follow a few basic tips for both these types of questions. So we'll do the first type first when the set notation is given to us and we'll be required to shade the required region. So that's one type of question. So we are doing case one. And there again, we can expect two more things here. As per our syllabus, either we would be having the diagrams based on two sets, or we would be having the diagrams based on three sets. So these are the only possibilities in our syllabus. Either it's two sets or three sets. So first we'll have a look at the two sets cases, and then we'll have a look at the three sets cases. All right. So let's say this is set A and set B. And what we have to do is, let's say we have to shade A intersection B. Then we can bring in the complement. Now let's say this is A complement intersection B. Let's say this is A intersection B complement. Let's have the unions also involved. Maybe A complement union B, or how about A union B whole complement, and A intersection B whole complement. So these are randomly different types of questions picked up. Okay, few things should be remembered when it's about shading the regions or shading the Venn diagrams based on the set notation given. So what you need to identify is how many different regions are there, what you have to consider. So for two sets, the maximum number of regions what we can have is we have 4 different regions. So it's always advised to label the regions first. So 4 different regions are these: 1, 2, 3, and 4. Let's label all the possible regions in the Venn diagrams first. After labeling them, try to find their associate sets. A intersection B. A intersection B, if you have to find A intersection B, the correct set here, it would be A, we know that it's 1 and 2. B, we know that it's you don't need to show this working. This working is just to have the correct answer. So either you use the curly bracket or round bracket, it doesn't make any difference because this is not the requirement of the question. The requirement of the question is just to shade it. 1, 2 intersection B is 2, 3. So here you can clearly see 2 is common. We can directly shade the region 2. After shading it, you can remove the marking star. So this approach helps us in reducing the errors and we get the correct region identified to be shaded. So we'll follow the same step for all these diagrams to be shaded. For the second part, we'll do the same thing. We'll first label the regions. We have altogether 4 regions here. 1, 2, 3, 4. After labeling them, let's find the exact region to be shaded. A complement intersection B. So for A complement means everything other than A. So A complement includes 3 and 4. Intersection B. For B, we have the regions 2 and 3. And finally, what is common between the two is the region 3. Region 3 is common between the two. We'll shade the region 3 only. And rest of the markings, the labelings, you can erase them. All right. Next part is A intersection B complement. Again, we'll start with the same steps. Acha, it's not necessary that you label the regions in the way I am labeling it. You can also use the alphabets A, B, C, D. So if I use the alphabets A, B, C, D, for example, this is A. I'm starting from outside. This is A, this is B, this is C, and this is D, right? All right, so for A intersection B complement, A, it would be having the elements as D and C. Intersection B complement means everything other than the set B, which is A and D. So what you can see common here is the region D. So you'd label or you just shade the region D only. Region D. So the point of explanation is you can either use the alphabets or you can use the numbers. Both will work because they only help us in identifying the correct regions. And even then you don't need to show this working. This is not the part of working to be shown. This is something what you are doing for just for your convenience and just to be on the safe side that which is the correct region to be shaded. Moving on, we are making the use of union now. So this is A and this is B for us. All right, A complement union B. So we'll start with labeling 1, 2, 3, 4. A complement union B. So A complement means everything other than A, which is 1 and 2. Union B. B, it's the complete set B, which is 2 and 3. And what union does is union combines the elements. So if I combine the elements, the result, it would be 1, 2, and 3. So except 4, everything would be shaded here, except 4. Except 4 means this whole part will be excluded only, and rest everything would be shaded inside and outside the sets. All right. Next part is A union B whole complement. A union B whole complement. If we label the regions, we have 1, 2, 3, 4. A union B. So what A union B does is, first you will find A union B. A union B means combining A and B. So A union B, it's 1, 2, and 3. This is A union B, right? A union B, this is you combine. A and B. And its whole complement, A union B whole complement now. So complement means everything except 1, 2, and 3. So in this whole Venn diagram, except 1, 2, and 3, what we are left with is region 4 only. So 4 is the region to be shaded. And here 4 represents everything outside the two sets A and B. Next part, A intersection B whole complement. So 1, 2, 3, 4. A intersection B. So A intersection B, we know that it's the common of A and B. I'm writing it directly, which is 3 here. Now its whole complement, A intersection B whole complement, it would mean everything other than 3. Everything other than 3 would be having the region 1, 2, and 4. So except 3, every single thing would be shaded. Is this all clear up till now?
Yes.
So for two set, this was one type of question we can expect, where the two sets are having one common region. In two sets, just a minute. Okay. So in two set, we can also expect these type of questions, a set within a set. These type of questions also comes in past papers, a set within a set, which is the case of a subset. So if let's say this is set P and this is set Q for us. P, Q, P, Q. And type of questions, let's randomly write this as maybe we have first as P intersection Q, P in P complement union Q, or P intersection Q whole complement. So whatever the set is, whatever the set notation, you don't need to be worried about the set notation. Just follow the basic. You have to see how many regions are there. For the previous question, there were 4 regions to be considered. Here altogether, we have only 3 regions to be considered. So 1, 2, and 3. Only 3 regions should be considered. So P intersection Q. P intersection Q means for P we have 1 and 2. Intersection for Q we have only 2. So the common between P and Q is 2 only. So 2 means this ring would be shaded. Next part, labeling the regions. I'm using A, B, C now just for a change, A, B, and C. P complement. P complement means everything other than P. So everything other than P, it's C only. Union Q. Q is only the region A. So their union would be C and A combined together. So C and A being combined means here in this case, everything would be shaded other than B. Other than B, every single thing is being shaded. Next part, P intersection Q complement. P intersection Q whole complement. Here, we do the same thing. Label the regions first. A, B, C. So P intersection Q. P intersection Q. P intersection Q. This is the common of P and Q, and common of P and Q, it's the region B. And now it says P intersection Q whole complement. Whole complement now means it would be everything other than B. So everything other than B means this would now be the region C and the region A. Okay, now there is a very important point of observation here for you people. Look at the two answers there, the part 1, the part 2, and the part 3. The important observation here is part 2 and part 3. And the observation here is we have different set notations here, and the two different set notations are giving us the same shaded region. The two different set notations were P complement union Q is giving us the same result as P intersection Q complement. So that means to get the same region, you can expect two different set notations. And for the second type of case, what I have discussed earlier, the shaded region given and you have to write the set notation. That means for one same shaded region, you can expect two or more possible answers. So two different set notations giving us the same shaded region answer is an indication that one same shaded region can result in two different set notations. Okay, so this was everything about two sets, how you shade the two sets when their set notation is given. So in two set, we can also expect these type of questions, a set within a set. These type of questions also comes in past papers, a set within a set, which is the case of a subset. So let's say this is set P and this is set Q for us. P, Q, P, Q. And type of questions, let's randomly write this as maybe we have for us as P intersection Q, P in P complement union Q, or P intersection Q whole complement. So whatever the set is, whatever the set notation, you don't need to be worried about the set notation. Just follow the basic. You have to see how many regions are there. For the previous question, there were 4 regions to be considered. Here altogether, we have only 3 regions to be considered. So 1, 2, and 3. Only 3 regions should be considered. So P intersection Q. P intersection Q means for P we have 1 and 2. Intersection for Q we have only 2. So the common between P and Q is 2 only. So 2 means this ring would be shaded. Next part, labeling the regions. I'm using ABC now just for a change, A, B, and C. P complement. P complement means everything other than P. So everything other than P, it's C only. Union Q. Q is only the region A. So their union would be C and A combined together. So C and A being combined means here in this case, everything would be shaded other than B. Other than B, every single thing is being shaded. Next part, P intersection Q complement. P intersection Q whole complement. Here we do the same thing. Label the regions first. A, B, C. So P intersection Q. P intersection Q. P intersection Q. This is the common of P and Q, and common of P and Q, it's the region B. And now it says P intersection Q whole complement. Whole complement now means it would be everything other than B. So everything other than B means this would now be the region C and the region A. Okay, now there is a very important point of observation here for you people. Look at the two answers there, the part 1, the part 2, and the part 3. The important observation here is part 2 and part 3. And the observation here is we have different set notations here, and the two different set notations are giving us the same shaded region. The two different set notations were P complement union Q is giving us the same result as P intersection Q complement. So that means to get the same region, you can expect two different set notations. And for the second type of case, what I have discussed earlier, the shaded region given and you have to write the set notation. That means for one same shaded region, you can expect two or more possible answers. So two different set notations giving us the same shaded region answer is an indication that one same shaded region can result in two different set notations. Okay, so this was everything about two sets, how you shade the two sets when their set notation is given. Another type of question what we can expect is dealing with the three sets now and shading them. So let's call these sets as A, B, and C. A, B, C. This is again A, B, C. This A, B, and C. And I'm just randomly picking up a few cases here. Let's say the first one we have to do A intersection B intersection C. Then let's say we have A intersection B union C, or A complement intersection B union C maybe. Okay. All right. So the basic remains still the same. And the basics are you have to see how many regions are there and you label the regions first. So for these type of three sets, we always have 8 regions. If I have to label them, this is going to be 1, 2, 3, 4, 5, 6, 7, and 8 is outside. Acha, to keep the thing simple, it's advised to add a bracket yourself. Sometimes they do give a bracket between two sets, and sometimes they don't. So if they are not giving you the bracket between two sets, you can apply the bracket yourself to keep the thing simple. For this, the first part, A intersection B intersection C, I'm adding the bracket myself here for A and B intersection C. So first I'll focus on A and B, and then I'll find the intersection of A and B with the set C. So for A and B, I'm doing it directly. A and B, look for the common of A and B. So for A and B, the common part is this hole. This hole. This hole is there in A and B. So I'm writing 2 and 5. Intersection C. For C, we have how many regions for C we have? For C, we have 4, 5, 6, and 7. This is all there in C. So 4, 5, and 7. Finally, the common region to be shaded is region 5, intersection. It's 5 only to be shaded. So 5 to be shaded means this is the final answer. Next part, A intersection B union C. Here again, I'll add a bracket myself. Choice is yours. If you want to keep a bracket between A and B or B and C, both will give the same result. So this time I'm adding a bracket on the later two sets, B union C. Okay, B union C. If I've labeled the regions first, 1, 2, 3, 4, 5, 6, 7, and 8. So B union C, what B and C does is, union does it, they combine. So combine of B and C, it would be 2, 3, 4, 5, 6, 7. Intersection with A. A we have is 1, 2, 4, 5. Finally, the intersection, the common part. It's 2, 4, and 5. 2, 4, 5. Okay, 2, 4, 5. So 2, 5, and 4. Yeah. Next part. This is again labeling the regions. So 1, 2, 3, 4, 5, 6, 7, 8. I'll add the bracket myself. I am adding the bracket here. A complement intersection B union C. So A complement intersection B. A complement intersection B means A would be removed from B. Remember the shortcut intersection complement. If it says A complement intersection, if this as a whole is used, A complement intersection, then it means remove A. If it says B complement intersection, B complement intersection means remove B. It's a shortcut to be remembered. If it says, for example, if it says intersection C complement, for example, the intersection C complement means remove C. Remove C. Okay, so I'm focusing on this here, A complement intersection. A complement intersection means remove A from B. So remove A from B means you'd be left with remove A from B. So from B, B is 1, 2, 5, 6, right? B is 1, 2, 5, 6. So from 1, 2, 5, 6, if you may remove A, you'd be getting only 1 and 6. So this part is 1 and 6. Union. And for C we have is 4, 5, 6, 7. Finally, their combined answer it would be 1, 4, 5, 6, 7. We have to shade these 1, 4, 5, 6, 7. So 1, 5, 4, and 7. Okay, so this is all about shading the three regions. Is this all clear? Or do you want me to do one more example? Guys, is this clear?
Yes, sir.
Yes,
Or should,
sir.
or should I do one more example related to it? I'll do one more example. So let's say this is now PQR. And I'm using the complements here. So this time I'm saying uh, P intersection R whole complement intersection. Okay, shortcuts to be remembered as we discussed earlier, intersection complement case. So you see intersection and complement is there. The intersection and complement is there. That means you'd be removing complete P and R from Q. Let's follow the steps. If you cannot do it directly, 1, 2, 3, 4, 5, 6, 7, 8. So P union R, P union R, it would be 1, 2, 4, 5, 6, 7. This is P union R. And its complement, this is P union R, right? This is P union R. And P union R whole complement, that means removing it from the universal. Removing it from the universal, we'd have 3 and 8. And its intersection with Q. Intersection with Q, Q we have is 2, 3, 5, 6. Finally, the intersection between both, it's 3 only. So 3 to be shaded. Okay. And then you can move the additional numberings. All right, so this is all about shading the field. And this was all about the first type of questions that we are given with the set notations, and we have shaded the diagram for both 2 sets and 3 sets we are done. And now we are going for the second type of question, which is shaded region given, and you have to write the set notation. Now, this is a scenario, this is the case where students sometimes make mistakes when the shaded region is given and you're supposed to write the set notation. And for this, you have to remember a few basic tips. Like here, consider these cases. The results. The result of A complement intersection B. Look at the result here. As I said earlier, intersection complement. Or please bear this thing in mind. Intersection complement means that you have to remove that part. So A complement intersection B means you have to remove A from B. What does this mean is you have to remove A from B. I'm repeating this word again, intersection complement. Wherever you see intersection complement, that means you have to remove that set. Intersection complement, you have to remove it. Intersection complement. Look at this third case, case 3 now. The third part here. The result of third part, that means this is now B being removed from A. You see, there is no part of B involved in it. That means B is removed from A. That is why it's A intersection B complement. So A intersection B complement means this B has been removed from A. So remove B complement intersection means remove B from A. So this is how you handle intersection complement. Next thing about union to be remembered. So this was few tips to be remembered about intersection. Few things to be remembered. And now about union to be remembered. So whenever you have union involved, union B means complete B should be there. So wherever you see union, that set has to be completed there. Always, whenever you see union, always shade that union part first. Oh, sorry, always shade the union part later. But that union part has to be there. So you see, in second part, it's A union B whole complement. So what you do is A union B means combine A and B together, and whole complement means now remove them from the complete universal set. So A union B means first you combine A and B. A union B means you first combine A and B, combine A and B, and remove from universal. Okay, so these are the few tips to be remembered for doing the reverse case. Reverse case means the shaded region given and set notation is to be identified. So I have picked up a few questions from the past paper here. Now, the first part, just a second. So first part, it says use set notation to describe the shaded region. Now look at the shaded region here. This is only part of N here with no M. With no M means M has been removed from N. And whenever it's a case of removal, it's always intersection complement. Since M has been removed from N, so M has been removed from N, we'll write this as N intersection M complement. Either you write in this way or you write it as M complement intersection N. They both mean the same thing. That means a part of M has been removed from N. Okay. Second example. Use set notation to describe the shade region in the Venn diagram. Now, if you may see here, everything is shaded, right? Every single thing is shaded except this common region. The except common region means you have to think. Common region is the intersection. This is X intersection Y. This is a common region. And this has been removed from the universal. So remove from the universal means for removal from the universal, you always take complement. So after finding their common, you are removing it from the universal. I repeat again, two steps. After finding the common X intersection Y, you remove it from the universal. So it would result in X intersection Y whole complement. Is this clear? Is this all clear?
Yes, sir.
Okay. Next example. Third part. So what do you think? What should be the answer for here, the third part?
A union B union C whole complement.
Excellent. So that means A, B, and C, they all have been removed from the universal. So first you combine them, A union B union C, first you combine them. And after combining them, you're removing it as a whole from the universe, so giving us A union B union C whole complement. Part 4. What do you think about this one?
A intersection C intersection B complement.
A intersection C, no. Look, what they have done is they have removed A and C from B. They have removed A and C from B.
A
So
union C whole complement intersection B.
exactly. So first you combine A and C, and then you remove it from B. So either you write A union C whole complement intersection B, or you write B first. It's the same thing. A B intersection A union C whole complement. That means removing A and C from the universe. And then there's one more way of writing it. You can also write this as B intersection B removing A and removing C. So both these answers are acceptable. Okay, the third part, the fourth part, sorry. This is fourth. No, sorry, this is fifth. This is fifth and this is sixth. What do you think about these ones?
P union R union Q complement.
P union R is correct, and you are removing Q from it, right? So removing Q from it means it would be intersection Q complement, because you're removing Q from P and R, isn't it? Is this correct? Or another way of writing is you're removing Q from P, as well as you're removing Q from P union, and you're removing Q from R also. That's another way of writing it. So both these answers are acceptable. Is this clear?
Yes, sir.
This last part. You are removing B from the intersection of A and C.
A intersection C intersection B complement.
Excellent. Okay, so this was all about shading the Venn diagrams. I have picked up a few questions for you. These 4 questions. I'm giving you 5 minutes of time. Quickly solve these and let me know the answers. All right, so these are all the correct answers for the questions given to be done. I hope you have got all these answers correct. Thanks for watching.